All right, welcome to a video on piecewise functions. Excuse my voice, I'm a little under the weather right now. So I wanted to make this video so I didn't have to teach it this lots of times today. So we're going to evaluate piecewise functions and we are going to graph them. So real quick, a piecewise function, think about it as pieces of a function. So it's defined by one or two or more equations. And each piece is going to apply to a different part of the domain. So for example, you have f of x, we've got two functions, and we've got two different domains. So notice x minus 2 is going to represent the value of f when x is less than or equal to a 0. And then our second equation will be when our domain is going to be x is greater than 0. So the biggest thing from middle school you should remember is if it is equal to, your circle is closed. And if it is not equal to, your circle is going to be open. So that is going to be a great part to help you today. So let's get started. So we're going to start off with evaluating. So for the functions on the right, find the following. So I have f of negative 6, f of 5 over 2, etc. If you remember, f of x is the number in parentheses. So what this is saying is your x value is a negative 6. So I'm going to come over here to my functions. The left side are your functions and the right side are your directions. So you have to figure out this negative 6 number, which direction does it apply to first? So negative 6, is it less than a negative 2? Is it between a negative 2 and a positive 5? Or is it greater than a 5? So this first equation is going to be less than a negative 2. So if we wanted to highlight, this lovely function would follow into the first direction. So I'm going to plug in my value of x into my equation. However, there is no value of x in this first function. So what that means, the answer is 3. So if anything is less than a negative 2, so like think negative 3, negative 4, negative 5, negative 6, so on and so on, the answer is just automatically going to be a 3. Okay. So I forgot to talk about this over here. Real quick, again, this inequality just means that x value is going to be less than a negative 2. This inequality over here is inwards, meaning that the number is between a negative 2 and a 5, and it can be including those numbers. And our last function, x has to be greater than a 5. So let's talk about another one. I've got 5 over 2, and if you divide 5 by 2, you would get 2.5. So then we have to ask ourselves, 2.5 is going to fall under which of these directions? 2.5 is a positive number, so it's going to fall between a negative 2 and a positive 5. So I need to take this 2.5 and plug it in where I see x in this middle function. So you're going to start off with 2.5, your x value, and then add a 2. 2.5 plus 2 is 4.5, and that's our answer. Moving on, I want to find f of negative 2. So I'm going to come over here to my directions. I've got a negative 2 two times. So if it is equal to negative 2, it needs to be plugged into this middle equation. So I'm going to take negative 2 and replace it right here in this equation. So I would start off with negative 2 and then add a 2, which we know negative 2 and a positive 2 will cancel out to give you a 0. Let's move on to f of 8. So the number 8 will be greater than a 5. So that's going to follow into my third function. So I'm going to take 8, plug it in where I see the x, substitute it. So I would have 4 times the value of 8, which is 32. So that would be our answer for evaluating. One more. I've got f of 4. 4 is not greater than 5, which means it's going to fall in between a negative 2 and a positive 5. So I'm going to take 4, substitute it into my middle equation. So I would have 4 plus 2, which we know is 6. So when you are evaluating functions, you're taking the number in parentheses and substituting that in for your x values, making sure to substitute it into the correct function based off the domain ranges. All right, let's do another one together. Let's add some quadratic and some lovely fractions to our equation. So remember, this right here means if your x value is less than a -4, but not including -4. So think -5, -6, so on and so on. Right here, this means your x value falls between a -4, including a -4, and all the way to a +2. And then the last function represents x having to be greater than or equal to a 2, so including the value of a 2. So starting off with f of 5, 5 is going to be greater than a 2. So I'm going to take 5 and put it into my last function. So I would have 3/2 parentheses 5 plus a 1. Now again, you could do mental math, or you could head straight to your calculator and say 3 divided by 2 times 5 plus 1, and our answer is 8.5. So totally up to you if you've got a calculator or not. Next one, -5 will fall in between our first one. So -5 would be less than -4. So I'm going to take -5 and plug it into my first function. The biggest thing when you've got an exponent of a 2 is you need to make sure to use parentheses when you are substituting. Otherwise, your calculator is not the brightest at that. So parentheses, -5 squared, and then subtract a 3 to get 22. So let me show you, if you did not put parentheses, your calculator would get it incorrect. So when you're substituting a negative number into a quadratic, make sure you're using parentheses. Next one, f of -2. -2 would fall between a -4 and a +2. So I'm going to take this -2 and substitute it into my middle equation. Now I'm going to subtract a negative, which looks a little weird. So I would have 10 minus, and then I am substituting in my -2. And if you'll remember, if you subtract a negative, that is really like adding. And so you would have 10 plus 2, which is 12. So again, you could type that in the calculator or do some mental math. Y'all try these last two. Press pause, and I'm going to pop up the answers in a second. Press pause. All right, so on the f of -4, -4 is including -4, so it's going to be in this middle function. So I'd have 10 minus a -4. Again, that would turn to a plus, which tells you how you get 14. F of 2, again, look at these symbols. It needs to be including a 2, so it's going to be this last equation. So 3/2 times 2 plus a 1 would get you a 4. So that is how you evaluate functions. Looking at your domains over here first to figure out which function you plug it into. So let me know if you have any questions on that. But now we're going to head to graphing. So the first thing, I'm going to teach you how to do this without a calculator, and then I will show you how to graph it in the calculator. So we've got two piecewise functions. They're both linear functions, you can tell from the graph. So I want to kind of break this down over here. So if x is less than or equal to 0, that is a fancy way of saying that's the left side of the graph. So to the left of a 0, here is our function. Over here, I've got to the right of a 0. So you can see I've got a left side and a right side, left side and a right side. So that's going to help us out. This first function you've got x plus 1. We know we can put an imaginary 1 here. So my slope is a 1 and my y-intercept is a 1, which means my line is increasing and going up. So if you want to jot that down, I've got a slope of a 1, a y-intercept of 1, and my line is going up. That's going to help me visualize it. Over here, my slope is a negative 1, and I don't have a y-intercept. So that means my line is going to be going down. Okay. Lastly, if it is equal to a 0, I need to figure out if it's an open circle or a closed circle. Equal to means my circle is closed. Okay. If it is greater than but not equal to, that means my circle is going to be open. So knowing all this knowledge of slope and y-intercept, the left side of the graph, the right side of the graph, and your circle being open, closed, you can figure out which graph it would be. So on the left side of the graph, I need a closed circle. The left side has a closed circle. This left side has an open circle. Not that graph. This left side has a closed circle. Looks good. This left side has an open circle. Not good. Okay, so just by knowing your open and closed circles, we can narrow it down between the following two pictures. Fun fact, these two pictures are the exact same. The only difference is your domain and your range. And if we notice, this is covering every single all real numbers. So my domain would be all real numbers. Also my range value, these graphs don't go above a 1, they only go below a 1. So my answer is the third one. Now, if you would like to know how to graph it in the calculator, I will show you that now. So in our calculator, if we want to graph, we're going to press y equals. In y equals, to get to the piecewise, you're going to go to the math function on the calculator. And I'm going to scroll up, or you can keep scrolling down until you hit piecewise. Hit enter. And then it will ask you how many pieces you have. And so I've got 2 pieces. So I'm going to scroll down to the number 2 and go down and hit OK. So if you do not have the CE TI-84 Plus, it's going to look a little weird, and I've linked another video on Canvas of how you can do it if your calculator does not look like mine does currently. Then I'm going to type in the first equation. So I've got x plus 1. I'm going to type in my second equation, negative x. Now the tricky part is over here with the domain restrictions. So you can either use this x, which I'll do, and then to find the less than or equal to sign, it is under the test category, which is in blue. So I'm going to hit blue and then math, and that will pull up all your inequality signs. So I want a less than or equal to, and then a 0. I'm going to go down, and now I want to do x greater than. Again, you're going to press second math to pull up the test and find our greater than sign. So once you've got that typed in, you're going to press graph. The sad part is it does not give you the open and closed circles, so you do need to know that. But this will at least help you identify the correct shape of the graph. So knowing that this left side would need to be closed in because it was equal to. And that's how you graph. Cool, cool. Let's try one more. I actually have 60 seconds left in this video, so you guys try number 2 and number 3. You can either graph or use process of elimination, and we will talk about it. So press pause, and I'll show you the answer. On this second graph, we could eliminate the last 2 answers because I had a line going down and a line going down, and if your slope is positive, it has to be going up. If you graphed it on the calculator, you would actually notice it is off the grid, because notice these numbers go all the way to 32. If you go to zoom and go to out and hit enter, it would then show it for you. So notice you have a less steep slope and then a more steep slope, which would be this second one. Our last one, if we graphed it, we get the following. So we're between A and C, and then notice the left side of your graph must be an open circle, which would have to be D. So if you have any questions, please let me know. Thank you for watching Piecewise Functions.